Hey, this is Dr. G talking to you today. I know that sometimes calculating probabilities can be really difficult, right? The mean of a probability distribution, the standard deviation, the variance of a probability distribution. And I want to give a huge shout out to a student. I wish I knew the student's name, but I discovered they showed me how to do this, and so I want to share this with everybody on my channel, right? And so this is U.S. Census family data from 2020. It's family households by type, age of own children, blah blah blah. Again, this was collected by the Census Bureau, and so it has total family households. So total family households, that too right there in the footnotes, it includes traditional and non-traditional families. And so it's obviously a slightly larger number um, than the married. So this would be strictly opposite sex couples. Uh, but I'm going to use this one, even though it's slightly smaller, because it goes up to more uh, kids. It goes up to more kids. So I'm going to use this data right here that you see highlighted. And what I did was I basically copied and pasted it into StatCrunch, right? So here's my size of family. So 2 members in the family would mean X is there are 0 kids. 3 members would mean 1 kid. 4 members, 2 kids. 5 members, 3 kids. And then, of course, 7 or more. This is actually where I fall. I have 5 children in the house right now, and I actually have 6 biological children. But for the purposes of the census, it would be the 5 kids in the household. Now, what I did was I actually took the 62,342 and I divided each of these counts by that to get the probability. Now, you'll recognize that as a relative frequency. So I turned the counts into a relative frequency, which is the probability. So the probability of a U.S. household in 2020 having 0, 1, 2, 3, 4, or 5 kids, if it was a traditional family, would be these probabilities right here, right? And so now, what if I wanted to find the average number of children? Now, obviously, 7 or more is not just 5, but because it's less than 2%, we're going to pretend like it's just 5, and then that way we can do this probability calculation. Now, you have probably seen me use the stat calculator a bunch, right? I've done it for the binomial on a lot of different ones. I've done normal and t-distribution videos before, but this is the very first time that I'm going to use the custom calculator right down here at the bottom. And my values are in X and my weights are in P of X. Okay, and then I don't need any where or anything like that. And I'm going to click on compute. And what you'll see is that for a household with 1 kid, it would be, with 1 kid is exactly 19%. 1 kid with 0 in it, not 10, 0 in it is going to be the 46.9. And so this is my actual probability distribution right here. And what's super cool is that StatCrunch has actually calculated the mean and the standard deviation for you right here in a super duper easy way. I love this. It makes me happy. Hopefully it makes you happy.